Okay, this lecture is over the exponent or the power rule, which we've already touched on this year. So the first several are going to be really easy and really familiar. And then we're going to start doing the same stuff, but using fractional exponents, negative exponents, dealing with some different applications of this same rule. So what we learned before was the shortcut for a function that is written ax to the n. And in this, a and n are numbers. Okay, so something like 3x squared we've done before. Okay, so there's going to be lots and lots of shortcuts that we learned this year, and this is just one of them. This does not apply to anything with sine or cosine or logs or arc trig or anything like that. This applies to simply things that have a power. And so the derivative was, the shortcut was that we took the exponent and multiplied it by the coefficient, and that n times a, and then we took the old exponent and subtracted by 1. Okay, so we've already done that, so we're going to try several, and I'll go through these really quickly for the first three, and then they'll change a little bit. So for number 1, our derivative would be 12x to the third, and then remember the derivative of any constant, any number all by itself is 0. So number 2 here, the derivative would be 10x to the fourth plus 7. So whenever we had an x to the first here, that would be 1 times 7, and then x to the 0. And remember, x to the 0 is just 1, so we just leave that as that constant. And the derivative of 1 is nothing. So the third question, we would have 15x squared plus 14x, and then we would be done. So these are more common things that we see, but there's all kinds of exponents, and they can be any number at all. It doesn't have to be an integer, it doesn't have to be a whole number or anything like that. And so we start seeing the same process when we see fractional exponents or negative exponents. We're still going to follow the exact same thing. So for number 4, we would have 20x to the fourth minus, and then we would multiply 3 halves times 6 and get 9, x to the, and we would subtract 1 from 3 halves. So 3 halves minus 1, and if you did a common denominator, you would have 3 halves minus 2 halves, which is 1 half. So most of you should be able to do that in your head without having to write down what I just wrote down. But as a little trick for you, as you're going through and subtracting 1, if you will subtract the numerator minus the denominator and put it over the old denominator, you will get the correct thing every time. Okay. So then we move on to the 2x to the 1 half, and so we multiply 2 times 1 half and we get 1. And then we take 1 half and subtract 1. So if you try that little trick I just said, you did 1 minus the denominator, numerator minus denominator, over the old denominator, you get negative 1 half. Okay, and that's your derivative. It's the exact same process, it's just dealing with fractions instead of integers. Okay, so when we look at 5, the derivative here, we'd have 3 times 4 thirds, which would be 4. X to the 4 thirds minus 1 is 1 third. And then plus 2 thirds, 2 times 1 third, x to the, and 1 third minus 1 is negative 2 thirds. Then we have negative 2 times negative 6, so we get plus 12. X, and we subtract 1 from negative 2, which gives us negative 3. And then lastly, we have 8 times negative 1 half, which is a negative 4. X, and we take the numerator, subtract the denominator, we end up with negative 3 halves. There's our derivative. So all the way through, if you see I labeled them f prime, I probably should have labeled them y prime. Those are going to be interchangeable. But these problems specifically labeled it y. So I need you to understand something, though, that this derivative is not the original at all. It is the equation for the slope. That's what that is, but that's the derivative. It's a completely different thing than the original. All right, so the question is that we started moving into fractional exponents and then negative exponents is, where do fractional exponents come from? So fractional exponents come from roots. So if I gave you the cube root of x to the first, that's x to the 1 third. It's always inside over outside. So negative exponents come from fractions. So if I had 1 over x cubed, that's the same thing as x to the negative third. So when we're doing this power rule, this exponent rule that was written up above, it has to be in the form number, power of the x to a number. It can't have a division sign in it. It can't have a radical in it. It is number x to the number. And so you may have to rewrite your original question so that it looks like that. And so even with the fractions, we had number x to the number. But they don't always come like that originally written. Okay, so we're going to work on several of these. And before you can take a derivative using that rule, they have to look like that form. And so for each of these, what we're going to do is rewrite them so that they look like that form. Then we're going to take the derivative. But something that you're going to have to do is be able to put them back in the original form. These types of questions are almost always multiple choice questions. And they are always, if they start with a square root, they're going to end with a square root back in the end. They're not going to leave it as the fraction. So the calculus that gets done is between the rewrite and that derivative. The other two steps to rewrite it and to go back to the original form are algebra skills. But if you don't have those, the calculus is going to be a moot point. Okay? And usually that's the part that students struggle with the most, is being able to rewrite and put back in the original form correctly. So for number 6, what we'd have to do is we'd have to rewrite it first. So this would be a root, so we're going to turn it into a fractional exponent, inside over outside. So that's x to the 1/2. Now it's in that form. Now I can take the derivative. So my derivative would be multiply the exponent times the coefficient, so 1/2 times the 1 that's out front, x to the negative 1/2. So that's the calculus that we're doing. But you're going to have to put your answer back in what I call the original form, which is the form that they gave it to you back in the very beginning. So if they used roots, they're going to use roots. If they used fractions, then you're going to keep the fractions. So this one used a root, so we're going to have to go back. But you also have to take into account now that we have a negative exponent. And we're not going to leave negative exponents. There was no negative exponents here, so we're going to have to employ fractions. And so something that you need to practice at is this back to the original form. So if I'm looking at this derivative, if I want to know what is going to be in the numerator, because I clearly am going to have a fraction involved because I have 1/2 there, I see that only the 1 is going to be in the numerator. That x to the negative 1/2 means it's going to be put on the bottom. That 2 is already on the bottom. So I'm going to write this, I'm going to have 1 over, and then that 2 is on the bottom. I'm going to move the x to the 1/2 down to the bottom so I can make it a positive. But I didn't have it in a fractional form when it came. I'm going to put it back in its root form. So hopefully we can start doing that in one step. That's the square root of x on the bottom. So this is what you have to be able to get to. That's the answers I'm going to read. That's the answers that are going to be on the multiple choice. But the calculus is right in here, in between those two steps. So it's going to take a little bit of practice for some of us. And that's what we're going to do today, is practice that. So for number 7, if we rewrite it, which is not the derivative, it's the same thing, we get x to the inside over outside 1/3. Okay, so then we're ready to take a derivative now. And so our derivative would be 1/3 x to the negative 2/3. So then the calculus is done, and now we're going back to putting it back in the original form. So if I look at what's in the numerator, all I'm going to have again is a 1. But in the denominator, I'm going to have a 3. And I'm going to have to move that x to the 2/3 to the bottom so that it will become a positive exponent. But then I'm going to have to put it back in the root form that it came in originally. And so that, putting it back into the root form, remember that 2/3 is inside over outside, so that's x squared, and then the cube root. So just a little note for you. If the original problem started with a square root, you're going to end with a square root. If it started with a cube root, you're going to end with a cube root. If it started with a fifth root, you're going to end with a fifth root. Because that is the denominator of your fraction, and that's not ever going to change. Okay, so that's a little check on yourself to make sure you put it back in the original form. At least got that denominator right. So number 8, we have the cube root of x squared. So to rewrite it, the square root of x cubed. To rewrite it, we have x to the 3/2, inside over outside. So our derivative would be 3/2 x to the 1/2. So 3/2 minus 1 is 1/2. So when I'm putting this back into the original form, even though this past two we put something else on the bottom, this exponent for the x is not negative. It's going to stay on the top. So our numerator is going to have that 3 and the x to the 1/2. But I'm going to put that back in the square root form, and then the denominator is just going to have the 2. You are more than welcome to write this as 3/2 times radical x. That's the same thing, but the radical x is on the top. All right, so we're going to try some more. So we're going to still have to rewrite. So number 9, we're going to rewrite this as x to the 2/3. This one is the cube root of x squared. So when we take the derivative, we're going to end up with 2/3 x to the negative 1/3. This x does have a negative exponent, so it's going to have to move to the bottom. The only thing that's left in our numerator is the 2. The 3 is going to be on the bottom, along with the cube root of x to the 1st. And there's our derivative. So the next two don't have any roots, but they come already in fraction form. Well, our power rule or exponent rule does not work with that. We have to write it as number x to a number. And so when we rewrite it, we're going to leave that 1 on the numerator where it is, but we're going to move that x to the top. But to move it to the top, we have to give it a negative 1 exponent. It originally had a positive 1 on the bottom. Now we're ready to take a derivative. So we would multiply negative 1 times 1 and get negative 1 x, and then subtract 1 from negative 1 and get negative 2. So the original form had a fraction, didn't have negative exponents, so we're going to put it back in that form. And so that negative 1 is going to stay on the top, but that x to the negative 2 has to move to the bottom and become a positive 2, and that's our answer, negative 1 over x squared. For 11, if we rewrite this, we're going to leave that negative 3 where it is and move that x to the top, so negative 3x to the negative 2. We're ready to take a derivative, so we multiply negative 3 times negative 2 and get positive 6. And we have x, and we subtract 1 from negative 2 and get negative 3. And then we go about rewriting it back in the original form, so it came in that fraction. We're going to put it back. That 6 is going to stay on top, and that x is going to move to the bottom, but become a positive 3 as the exponent. All right, so number 12 has a combination of what we've been doing. So to rewrite this guy, we're going to have to move that x to the top. So if you move that x to the top, it becomes, well, we're going to have to write it as an exponent first. So this originally is 1 over x to the 1/2. Okay, but we're going to have to move that to the top, so we get x to the negative 1/2. And now we're ready to take a derivative. So we get negative 1/2 x to the negative 3/2. So we subtract 1 from the negative 1/2. Now we have to put it back in its original form. We've got roots, we've got fractions. Okay, on the top, the only thing left on the top should be that negative 1. And on the bottom should be a 2, and this x is going to have to move to the bottom. It's going to go back into its root form. It's going to be the square root of x cubed. Okay. Last one, so this one's a little tricky in that you have multiple x's, and so far in our problem we've only had one x multiplied or divided together. Now added and subtracted is something different. We do those individually. But when they're multiplied or divided, we don't have a rule on that yet. We're going to have to combine these into one. So all of our rule had just a single x, and so there are a couple ways that you can do this, but they all involve rewriting it. So if you rewrote this, you could write it as 2x over the square, or x to the 3/2. And depending on your preference, you can either say, I know that when I have x on the top and x on the bottom, what I get to do is I get to subtract those exponents, and I would have 1 minus 3/2, or 1 minus 1/2, and get negative 1/2. Or if you don't prefer to do that, a lot of people will prefer to move that x to the 3/2 up to the top, but then it gets moved as negative 3/2. And when you have two x's next to each other that are multiplied, we add the exponents. And so we would add 1 plus negative 1/2, which is the exact same thing as us subtracting those, which is what we just did. And so when we rewrite this, we're going to rewrite it with just a single x that has a negative 1/2. Okay, so we had to combine our terms. Now we're ready for a derivative. Now it's just as simple as the previous questions. So we take negative 1/2 times 2 and get negative 1. And then we have x, and we have negative 3/2. Subtract 1 from that. And so when we go to rewrite it in the original form, what's left on top is going to be a negative 1. And then this x has to go to the bottom. And then we have to go back into its root form. Okay? And so there's our answer for that problem. So your assignment is going to have a bunch of these exponent or power rules, and you have to make sure before you take a derivative that you rewrite it so it's in the form ax to the n. You also then have to make sure at the end, if you have rewritten it in any way, that you go back and put it back in the original form. I will not read what I've written in all these pink answers, I will only read what's written in red. Okay, now if you didn't have to rewrite it at all, like let's say back at like 1, 2, 3, 4, and 5, we didn't have to rewrite at all. You get to go straight to the derivative and you get to leave it in that form. That is the original form. It's if you have to rewrite it to get it in ax to the n, you must put it back in the form that it came. Okay, so then the very last thing we're going to talk about are two different shortcuts. This has nothing at all to do with exponents. It's the derivative of sine and cosine. So here we've got one of them. Okay, if you have y equals sine x, the derivative, y prime, is equal to cosine x. The derivative of sine is cosine. Has nothing to do with an exponent. That's the shortcut. Okay, and then on the other hand, if you have y equals cosine x, its derivative is negative sine x. Okay, those are two other shortcuts that we're going to have to memorize. So what we have two to practice on, and those are pretty simple. Just as a note for you, if there is any number sitting out front, just a number, not a variable, a number multiplied out front, it's just going to stay there when you take a derivative. It doesn't multiply by anything, it just sits out in front as a coefficient. So if I ask you to take the derivative of y equals 3 sine x, that 3 is going to stay there, and I'm going to take the derivative of sine. So if I look back, the derivative of sine is cosine, and that's it. Okay. So same thing on number 15. Okay, we have y equals 5 cosine x. When I take the derivative, that 5 is going to sit there. And then I look back and have to take the derivative of cosine, and the derivative of cosine is negative sine. Now what you cannot do is write negative sine like this, because it looks like it's 5 minus sine x. So you have to do one of two things. You either have to put the parentheses around that negative sine x so that it's understood that 5 is multiplied by that negative sine x, or what most students end up doing is they put the negative out front here. They multiply the negative and the 5 together and get negative 5 sine x. Okay, and that's it. So you have homework 3.2, which will be due Wednesday. Make sure you go back and put them in the original form. That's the biggest thing that students miss.